Ishwari Namaha. My humble prostrations at the lotus feet of our most beloved Amma. My humble pranams to Sri Sivaprasad Velayudhan, Director Operations at the Realworks Studios. Happy to meet you again after probably the end of the pandemic.
Yeah. Same here.
Almost 2.5 years since we have seen you. So he's going to today deliberate on the 3D animation, the introduction to the production pipeline. That is his cup of tea. And since he's fully involved in this, he will be taking you through his rich wisdom of experience. And it is experiential knowledge what he's going to share with you. So let me take this opportunity given to me to briefly introduce Sri Sivaprasad. Is currently the Director of Operations, highly experienced with a demonstrated history of working in the media production industry. He is skilled in 3D visualization, computer animation, user interface design, the UID, the animation, open source integration. And he's too good at the operations management of an animation industry with very strong operations professional experience and his main focus of study at the campus has been the Master of Computer Applications MCA from the Bharatiyar University. He worked as a head visualizer in Black and White Multimedia Private Limited, India Private Limited in 2007. He worked as creative executive in Rage Communications, and he produced India's first 3D animated trailer using open source pipeline. At present at the Realworks studio, he is engaged in VFX for many Tamil films. Managaram, Kashmara, Puli, Master, Vikram, and commercials like Lalapakati Restaurant, to name a few. I'm sorry if I have done any mistake in pronouncing it properly.
Nothing at all, sir. It was all perfect.
He has been, during his visit, he has been always looking for the availability of any HR inputs from our institution because he values his institutional profile, and some of our alumni are still working with Realworks. This is something very amazing and we are all very elated about it. And surely because of all these connections what he has with our campus, he is also serving the Department of Visual Media and Communication as an academic advisor, and he is one of the members of the academic advisor committee, and he is contributing richly towards the development of the curriculum, development of projects, and development of the overall development of the department. He is one who is always accessible to us for consultation, and this we all value very much, his willingness to share his rich wisdom. So with these simple words of the profile what Sri Sivaprasad Velayudhan has, I profoundly welcome Sri Sivaprasad Velayudhan on behalf of the Faculty of Arts, Humanities and Media and Commerce of the Amrita Vishwavidyapeetham to our campus, and our students and faculty are immensely lucky that they are able to get one more session from you. And once again, very heartfelt welcome to Sri Sivaprasad Velayudhan. Over to you, sir. Initiate.
Thank you for a warm welcome, sir. Like as always, I feel at home, talking to you people. So I'll start then probably. Yeah. Okay. So as sir said, like I run a company called Realworks Studios. We are into animation, visual effects, and computer graphics. We take up anything related to computer graphics. That's pretty much what we do. Okay, it could be an asset development, it could be movie visual effects, or it could be a complete CGI ad. It could be motion graphics. It could be even small renders for print media. So anything a computer can create using graphics, we take it up. So that's what we do. But we mainly focus on full CGI stuff. Like instead of live action plus visual effects, we specialize on full computer graphics, like probably the Talapakati restaurant ad, which you just, were able to, see. So that's what we want to specialize on. But we also do all this stuff, like the regular visual effects and live action and print media renders and lot of other stuff related to VR, AR, gaming, and all that. So today, like I thought, this could be a very basic introduction of how 3D applications or 3D softwares can be applied in few of these areas. Okay, when I say areas, like I mean gaming and interactive design is one thing. Uh, Fully CGI animated stuff is one thing, and live action visual effects is one thing. So and I could split this into very fine stuff, but broadly interactive and full CGI and live action would be the broad categories. So when it comes to this, like when you learn animation, the term animation is a very broad thing. You can apply it to any field for that matter. Probably when somebody bowls in a cricket match, like there are people who analyze how he does the bowling, how the body mechanics work, whether the posture is right, like how these could be corrected to generate more pace, kind of thing. So people, and record all these movements, then analyze it and create a model where they teach the player how to correct their posture and this thing action and all that. So even that involves animation, tweaking and analyzing and stuff like that. So it's a very technical stuff when you look at it. And there are companies which use animation to operate robots, basically warehouses where things are picked and kept and arranged, rearranged, took up on request, and that kind of inventory management is done using robots. All these are run by softwares which knows animation. These are like purely technical stuff that I'm talking about. So it is done using programming, it is done using analysis of existing motion. They apply like lot of machine learning and AI stuff to analyze what's actually happening, then tweak the path of the robots and action of the player. Like they suggest a lot of stuff. So in simple terms, animating is giving life to something. It's like let's say I have a phone and I make it look like this has life. If it is still, there is no life. So if I just make it pop, if you forget my hand, you'll think that this guy has some life. This guy is going to jump into the screen, or jump away from the screen, or probably hit me or call me. So this is like giving life to an inanimate object is called animation. So what is very important, even for the very technical animations or a very simple animation, is that you understand what life is basically. Okay, so life, I don't think you'll be able to learn from any software, any book. So it's around you. So life is what happens around you, what happens to you. So when I say life, I mean it involves all the emotions, all the actions, all the gestures, all the languages that you hear. So it's. I mean even the fan. I mean in your room is animating. That has life. It does something. And the if you can visualize the air that is passing through the fan, that by itself is a very complex animation. And the room would be cool in certain areas because of the air flowing right below the fan. Certain areas would be warmer. So the thing is, like, you'll have to study what's happening around you. So imagine things through sound, and even observing every little detail, like when is light was switched off a couple of minutes ago, the camera would have adapted itself to be little brighter. If you look at it, like the way the camera adapted to show darker areas is as a uh, phenomenon of the camera sensor and the aperture. So if you don't do that, if you don't observe that, you will not be able to recreate it. So usually what we do is, like, make it dimmer or make it brighter, but it usually doesn't happen that way. It gets darker immediately, then it automatically gets the exposure right to get the faces and all the room as bright for us to see. So even a small observation, I think the video feed got uh, cut actually. Yeah, now it seems fine. Yeah. Okay. So the thing is, like, when you observe a lot of stuff, that is when you understand what happens, what are the small details that happens uh, to objects which make it look as though it has life. So it's a simple term. Probably animation. People always think about softwares, 3ds Max, Maya, Blender, or whatever tools that you work on. But please understand, forget all those tools. Just focus on life around you. Okay, you're planning to give life to an object that you get digitally. So you need lot of observation, a very little knowledge of software. I think that's how you'll have to balance it. Like 80% would be observation from real world and 20% would be a software. It could be any software. It could be 3ds Max, it could be Maya, it could be Houdini, Blender, Softimage, whatever you have access to, whatever you have tried. So now today I'll explain like how certain things are done, like what are the features available in tool called Blender. That is what we predominantly use. We don't use any other 3D package basically. So we use Blender exclusively for all our 3D animations, 3D visualizations, look development, and even compositing and editing, and all simulations as well. I'll just let you know, like in terms of game asset development and interactive design, like it's mostly asset development. You're just creating the models. So most of the time when you use any tool, you create models, either download models, tweak it, or create your own models from scratch. So it could be polygon modeling, nerves modeling, you could be sculpting it and doing a retopology. Retopology is like getting the uh, flow of polygons a little clear rather than messy triangles kind of thing. So that's basically modeling, and you would be focusing more on asset development, texturing, shading in game and interactive design. In terms of full CGI, you're creating the entire thing. It's the backgrounds are created, the vegetation is created, the foregrounds are created, the characters, cloth simulation, hair and smoke and fire and stuff like that. Everything is generated inside the 3D package, or whatever applications that you do. The third one is the visual effects, like live action plus visual effects. The main key element is you'll have to supervise your shoot no thoroughly, so that you get a very clear footage for you to work on. And before that happens, the pre-production is the key element here, wherein you'll have to sit and design all the shots, no discuss with the director and DOP of the movie, or of the short film, or the music video, to get the shots in place and decide what needs to be shot on the floor and what needs to be created in a in CG, and decide on what all elements you'll be creating in terms of green mat or interaction props kind of thing. So I'll just explain the digital side of things because that's easier to do in a webinar. I can share my screen and I can explain what all elements you'll be able to achieve, what all parts of the pipeline you'll be able to achieve. So I hope like few of you have, or most of you have used 3D tools. Like, am I right when I say that? Most of you have tried 3D software.
Okay. Yes, sir.
So most of the team here have no 3D tools, right? Like, yeah. Okay. So which tools have you guys used? Like Blender, 3ds Max, or Maya?
So we have a group of students who are already familiar with some basic 3D tools, and
Okay.
there are some students who are still waiting to get waiting to explore this interface.
Understood. Okay.
And there are some
Okay.
UG
Okay.
students also.
Right. Okay. So yeah. So I mean, but everybody would understand Photoshop or Illustrator, right? Like generally pixels and images. When I say when I talk about image processing, would that be fine, or like I directly go into uh, 3D interface and stuff like that? So the thing is, like, our goal is to create pixels basically. So as you already know, pixels is like a representation of real world again. Any color that you see, you plan to store it, and the way you store an image is a pixel. Okay, so most of the time, like uh, computer digital stuff has RGB. Okay, RGB represented as numbers, or split into bits internally. So we are planning to create all that. Okay, so anything that you see, how do you the way you create pixels is either from capturing through a camera, or drawing it and scanning it into a computer, or generating everything inside a computer. So there are only three ways to do it. So it's more like we are talking about generating everything inside a computer. That's what today's session is all about. Drawing and scanning is pretty straightforward. Okay, photography, you already have mobiles in your hand. It's just that. But the thing is, the first two methods of photographing and scanning, you don't usually get into the internals of how it is stored, how it is going to be used later. So once you get it on a phone, like it's just a photo and you just do some color corrections to it. But when you generate it, it really matters what you're going to do with that image. Basically, you can't create a JPEG image and expect a colorist at the end of the line while doing the movie grading uh, to have good color space. JPEGs don't have good color space. It's those are viewing formats. So what you have to understand right from the beginning is file formats are very, very important. So when you say JPEG or TIFF or PNG or BMP or DPX, EXR, there are lots of things which are happening under the hood. Okay, everybody talks about give me EXR files, give me raw files, give me DPX files. But why do we have all these these many formats? Can't there be one format which fits all this thing? So when you are learning a subject, basically you'll have to ask these questions yourself. It's like uh, there's a JPEG image, then there is this TIFF image. What is the difference? Okay, people would say like TIFF has alpha layer, there is transparency to it. Then what about PNG also has transparency. So there is a difference between JPEG, PNG, and TIFF. Okay, TIFF can have layers like Photoshop, but PNG cannot have layers. Okay, JPEG cannot have transparency. Okay, PNG is a web format. It can be compressed very much. TIFF also can be compressed. Okay, so there are many ways of compressing, lossy, lossless. So why I mean, probably this might sound like boring theory to you, but every day on a day-to-day basis I firefight this issue in my company. The files that we generate are not compatible with the studio. What they give is like, is in a different color space. So there are huge companies developing standards to manage this. There is a open source standard called Open Color IO, which was developed by Sony Imageworks to standardize all these things, because they were working with like 15 20 studios at a time for one single movie, and they wanted all the colors to be in place. So when you open Photoshop, you say 8-bit, you never even notice what the bit depth is, but you'll have to know what you're working for. For print, you clearly know, you have to work on CMYK and 300 dpi. But otherwise, like, there is not much uh, thought that we put on the file format, the bit depth, the resolution, the dpi basically. So these things are different. Dpi and resolution is the width and height of an image. Dpi is when you print it, when you print it on a paper or a film, how many dots does 1 inch have? That is dpi. Okay. Or if you are displaying it on a digital display, the dpi is either 72 or 96, nothing more than that. Okay. Why 72? Okay, these questions should come to you rather than reading it in a book, like 72 dpi for image, uh, and 96 dpi on a Mac machine. So that really doesn't hit you. So you'll have to actually ask the question, why 72? You might, can anybody tell me like what is the resolution of full HD? Pixel size, width by height.
Sir,
Any
1920 1080.
one? Why is it 1920? Why is it not 2000? Or why is it not 1900? No, because she got the mic. Like, I think she's stuck. Like, probably somebody can save her. No.
No, sir, I'm
Okay.
not disturbed. I'm thinking.
Good. So,
And
why do
sir,
you think?
your lesson is not boring. It's interesting.
Thank you. Thanks a lot. Yeah. Okay. So now, why do you think it's 1920, not 1900 or not 1950? Why not 2000? So I'll tell you one thing. I'm not going to answer any of those things. Okay. Because I strongly believe the questions are far more important than the answers. Because if I answer, there are a lot of people who don't go home and research on that. If I
Yeah.
no,
Yes.
now I'm not going to answer it. There are two reasons. There could be two reasons to it. Either I don't know, okay, or I don't want to answer. Okay, so you can take it whichever way you want, but I'm not going to answer. So now think about it, 1920. Then there are resolutions, like 720, 576, 640, 430. Okay, 640, 480, and a lot more. You can sit, please. Yeah.
Thank you.
So it's, and then there is 2048, 1160. There is like umpteen number of UHD, QHD, okay, XHD, and nobody asks these questions. Like when you go to a TV showroom, you say like, do you have UHD, or you have 4K, you have this thing. Just because like there is 4K TV available for a cheaper price, we get it, but there is no 4K content that we have no to play on it. No, I mean Netflix doesn't play 4K. Okay, so then why the hell would you buy a 4K TV? Buying like spending a lot more money on it. So the thing is like, if you understand a lot of stuff which went into developing all these file formats, these resolutions, it would make a lot more sense in creating it. Okay, so when you create a pixel, you don't want to spend too much time on creating unwanted pixels.
So
Peop- yeah.
I want to say that this the pixel size is 19820 and 1080 because of maybe, sir, it's heavy, means it not be heavy like that, means.
Yeah, then the question is, why is it not 1900? It could be little more, no, lesser heavy than 1900, right? Like, no. And then let's say, okay, imagine, there are reasons why it is smaller, I understand, but why specific number 1920? That is the question here. Okay, why is it 1920, not like 1900? Okay, it could be 1919 also, right? Like, why is it not 1919? Why is it 1920? So that's the question. So go explore, go figure it out. If you find the answer, please pass it across, no, through Dinesh sir or Hari sir. So I'll just get the answers, and I'll be happy that, like, no, you guys went and explored and figured it out. So now that's one thing. Now tell me, what is the frame rate of film? Somebody else, like, other than uh, frame rate of film. Somebody on the other side, probably. Nobody wants to answer. So even you guys are very clear that questions are important, answers are not.
24 FPS.
24 is film. What about like TV?
25.
25. Why 25? Why 24? You would also find like 30 frames, 29.97, correct? Why all those frames? Yeah, I mean, yeah, you're supposed to do the mic. She's very curious about answering. Yeah.
It's like we can see a flowy movements 24 and 25. That's why they put like that.
Yeah, I mean, lesser than 24 is, no, very jittery, that I understand.
Yeah.
So either you could have had 24 or 25. Then there is 29.97, then there is 30, then there is 48, then there is 60. Why do you need all the, I mean, it's super flowy in 60 frames. So as you said, it could be, they want it less heavy, so they made it like somewhere balanced, somewhere around 25 or 30. This is the assumption that we are making, but this is not the truth. Okay, so there is a specific reason. So I'll give you an interesting thing about 25 frames. Okay, so and why 30 frames? So
So
you'll know, like, uh, and this sorry, is it
standardization in TSN PAL.
yes, perfect. So that standardization happened because of one main reason, which is the, power outlet that we have at home in a specific country. Okay, we have 50 hertz power outlet. Okay, which means like 230 to 240 volts voltage is coming, and the uh, no, frequency is 50 hertz. Okay, when designing a TV, they had to create scan lines depending on this frequency. Okay, so what happens is, now it's a sine wave which moves 50 times in a second. So every cycle they used to scan one frame. Okay, so they can scan 50 frames in 1 second. Okay, but the data was too heavy. What they did was, like, they scanned the first line, third line, fifth line, the odd lines first, then the even lines. Okay, then they interlaced it. So that is the reason for having interlaced video. Okay, so interlaced video, they used 25 cycles for odd lines, other 25 cycles for even lines, so they could achieve in 1 second 25 frames. Okay, now 24 is the bare minimum number that you need to see for fluid motion, because our eye has persistence of vision, which is 1/24th of a second. These are the reason for all those numbers. Okay, now most of the time we are just, select it from a drop down. Even 1920 has all these reasons. Okay, 720 has all these reasons. Okay, displays were made with 72 pixels per square inch. Okay, so they couldn't achieve more pixels in 10 inches. They could achieve only 720 pixels in 10 inches. 10 inches was the maximum that they could achieve in a certain period of time, so they had to fix it. They didn't want it square, because usual human perspective is not square. So they wanted it to cut down to a rectangular thing. So these stuff may, uh, enabled all these decisions. That's how all these numbers came into being. Even 2K or 4K USD, there is reason to it. Okay, so if you don't understand all those fundamentals, you will not be able to create all these new formats. You could be an engineer who's working on standardization of TV and film content. If you want to be there, you need to know where it all started. Okay, so without knowing, how fire started, you'll not be able to create a mobile phone basically. So that's exactly what I'm trying to establish here. So you can learn any tool for that matter, but the understanding of the fundamentals, how it all started, how printing worked, how telegraph worked, how telephones work. That is when you get sending a message is the key here. So somebody used to write, roll it down, and send it through a pigeon. Okay, so you need to understand why this was done, how they replicated all these letters, how they printed, how they created all these stamps and created multiple printing stuff. Then they made it into a machine. Then they started recording light using sensors. They recorded sound using all these records, lacquer records, the earlier ones, gramophone records. So if you start understanding how real world was captured in cassettes, in films, in gramophone records, then you will understand how it is being done in digital formats, all these RGB formats. Even the sound, the audio that you're hearing is recorded in a certain hertz. So no, there are numbers to it. Okay, I might not be that proficient about audio, but basically the fundamentals remain same. This many hertz of audio, 20 to 20,000 hertz is what what human ear can hear.
Yes, sir.
So that is the number that they are fixed. That there is a ceiling to it, beyond which nobody is going to listen. So they don't waste that kind of hertz to it. So MP3 has a certain compression ratio. Wave file doesn't have compression at all. So you need to understand how these file formats work. That is where the pipeline starts. Okay, when you talk about animation or any content creation, you will need to understand what file you are saving into. Okay, so now let's say we are saving into PNG 16-bit. Okay, or creating PNG 16-bit or receiving PNG 16-bit. Now all these pixel processing is what we plan to do. Okay, creating it, receiving it from elsewhere, mixing both. Okay, so now there are tools to create all these pixels. Okay, most of the time the 3D tools that you see usually doesn't give you the pixels or resolution until you start rendering it, saving it. So you don't have to bother when you're creating the visual actually, but while you are writing it down, while you are rendering it out, you need to understand that there is a standard which you'll have to follow, which will be compatible with other studios or other team members of your team, or even for you to process it later. You'll have to have a clear understanding of what you're saying. Okay, so now that we have established the fundamentals are very essential, I'll get into the tools that no we use basically and show you what all is possible using Blender. No, that's how much time I think I'll have to no cover. So I'll not get too much into fundamentals or too much into theory. So I'll just show you asset development probably, and lighting, look development, shading, then rendering it out in various formats like compositing it. Look, I'll do a quick run. You can stop me whenever you want to. I mean, this is not. I mean, please keep in mind this is not a Blender workshop. I'm just using Blender to make you understand. No, these things are possible. Okay, these can be done in many other tools as well. Okay, cloth simulation. You have a specific specialized tool for cloth simulation. Okay, which is called Marvelous Designer. Then there is simulation tools like Houdini where you do all the destruction effects and rain and water and sand and everything. But what I'm showing right now is things that you'll be able to achieve using a very simple tool. Blender is a very, I mean, I wouldn't say simple, I would say easy. Okay, the tool is very complex, but you can get into it very quickly. It's easy to achieve, and it's free basically. So you don't pay a penny to download or use it on commercial projects. So why do you have to do it? Only if you are starting a business. Okay, you don't have to do it if you are going to uh, work in a company, because most of the companies don't use Blender. Of course, if you want to work in Realworks, you need to learn Blender. But otherwise, like, it's most of the studios use industry standard tools like Maya or 3ds Max or Nuke, stuff like that. But the companies which don't have money to invest initially would have started using tools like Blender, or free tools like Unreal or Unity. I mean, simpler tools like Unity for game development, or Godot engine for that matter, which is completely free. So there are lot of tools which are free. Okay, most of the tools are far better than the paid ones. Okay, so you might consider learning all these tools if you are starting a company. That's the key here. Otherwise, you might not be able to get a I mean, today Blender is very famous. Like, most of the studios have started using Blender in game engine game developments and asset development and stuff like that. You'll of course get good jobs if you learn Blender as well. But in case you want to get into character animation, I would recommend Maya. Okay, apart from that, everything else can be done in various other tools. Character animation like Maya, rigging, and uh, timeline and tracks editor, everything is like nice. Blender is not that proficient yet in that particular area, but otherwise, like, everything else can be done in Blender. And most of the studios which does other jobs are exploring Blender, or most of the studios have switched to Blender like in last 3-4 years. Okay, so you're kind of you'll be very well balanced if you know both. Okay, so knowing Blender is a good skill to have. Okay, now I'll just start by sharing the screen. I think you need me to make the presentation. So this is this is Blender. This is how it starts. uh, for those of you who have already worked on 3D tools, you might have a fair idea of what this is. This is the 3D view. Okay, and Blender is non-blocking interface. For instance, you don't have, whenever you want to work on something, you don't get a panel over the interface. Most of the interface is self-contained. There is this timeline, there is this property window, this is the outliner. All these things are non-overlapping. You mean, like, you don't get a window once you need to tweak materials. You don't get it over this window. You have it as a panel here. Okay, so just a second. Yeah, so it's like, you click on materials, you click on the world. These are scene settings, render layers, kind of thing. So it's a non-blocking thing. There are other tools where as soon as you click on material, this panel would pop here. You'll have to work on it. You'll not be able to see what's actually happening in the window. So Blender has a non-blocking UA. That's a kind of a unique feature for this. Like, there are other tools which does this, but this is kind of fairly, it doesn't, like, you are not stepping on other stores basically. So once you're doing materials, you're focused on materials, like, and you still can see what is happening in the 3D view. So this is the 3D view basically. And when you say this is an outliner, this shows what you have, okay, in this 3D view. It's as simple as that, nothing more than that. Whatever you have in this 3D view will be seen here. Okay, so I select the cube. You see that, like, it's an orange outline. That's what selection means in Blender. Okay, when you click on camera, you don't see anything being selected, but you see the border of this thing getting highlighted. When you click on light, you don't see anything because the light is not visible in this view. So this is the camera view. Okay, now I have moved. No, I have orbited this camera. So now you can see this is the light. Okay, this is how lights are seen in Blender. Okay, and as you would already have guessed, this is the camera. So once I select the cube, it's the highlight is moving there. Now it's the camera. Now it's the light. This is a default scene that you get when you open Blender. Now you can delete all these things, create your own content and stuff like that. Now I'll just try to you know do bit of stuff, making you understand how things are done. No, I use hotkeys because I'm used to it. I don't click on menus. Look, what I have done is like probably I'm very slow with all these menus. So yeah, so numpad 0, active camera. So this is what I did. So I clicked on numpad 0 and it went to the active camera. So you are seeing everything through this camera. Now, what if you want to move this? Okay, the first issue that everybody has when opening Blender is nobody knows how to move this. Okay, it's a very big issue. Most of the applications have it's fairly easy in other applications. The main reason is the tool of selection here is different. Now you click on move, you start seeing all these gizmos. Okay, this is your X, Y, and Z. Okay, so can anybody let me know why these colors? I mean, why are these colors this way particularly? What is these colors mean? These three colors, axis colors.
So to represent the axis.
Yeah, yeah. Why is it this color? Why is it not yellow, orange, or pink?
RGB.
Yeah, fairly very easy to remember, right? That's the answer. So RGB we already know. So essentially in that order, this is X, Y, and Z. So now that like everybody understands it's RGB and X, Y, Z, Blender has a unique axis this thing because Z is always up. Most of the tools has Z into the screen. Okay, now I wanted you to remember that. That's the reason I asked this question as well. RGB is X, Y, Z. So Z is up always. Okay. It's like 2D graph. It's like 2D math graph wherein it's X, Y, and Z is to. It's like viewing from the top. Most of the tools have viewing from the front. Okay. So remember that. Now moving is simple. Rotating again. If you click on it, it's fairly simple. Okay. I'm just navigating and doing stuff. Even scaling, it will show its own gizmo X, Y, and Z. And you don't have to click on any of these things to do this. You can just click R and rotate it. If you say X, it will rotate. After you click on R, if you click X, it will rotate only on X. Immediately you can switch to Y, it will rotate only on Y. You can click on Z, it will rotate only on Z. And say you wanted to rotate 45 degrees on Z. Okay, R, Z, you just type 45, it is rotated. So you don't even have to use your mouse to rotate something in Blender. Okay. Yes, of course, in case you need to rotate arbitrary angles, you use your mouse, but otherwise you can do everything using hotkeys. Okay, the same thing applies for scale as well. S is for scaling, X and 2. So it has scaled twice in x-axis. So this is the fundamental basic object manipulation of inside Blender. So I wouldn't be focusing too much on how these manipulations are done. I'll show you what is possible. If you have any questions, please feel free to ask anytime in between. Okay, so I can answer your questions basically. So this is like scale. This is like transform, entire transform gizmo is there. Like it's movement, scale, and rotation. Okay, you rotate it and you just move it and you just scale it. You can do everything. It's a uber kind of gizmo. Like, and these are like stuff like annotating on it. No, let's say you can like this cube is ugly, change it, and you save the file. Somebody opens the blend file, they'll see these comments. So these are tools for easy usage. Okay, now that we know how to move and rotate and scale, okay, let's focus on other things that we'll be able to do with any model. Okay, so this is a cube. Now you want to make this into a house. There are certain no operations that you'll need to make it look like a house. Okay, so I'll get away from the camera view. Okay, now in case you want to edit this cube, okay, Blender has one mode which is called edit mode. Okay, what you are seeing is an object mode. There are different modes to it. Okay, once you click edit mode, what happens is you start seeing the vertices and edges that this cube is made of. Okay, now again, like this is selection, this is your move tool. So in case you want to move any of these things, you have to click on move. Once you click on it, like you go out, you come back, you still be in that same tool. You don't have to worry, it will switch back to the other tool and you have to click every time. You don't have to click on it. Once you click on a tool, it stays there. So now you have selected vertices. Okay, you can move these vertices. Same thing applies. Gx1. Okay, G is grab, X is x-axis, 1 is 1 unit. Okay, so it's as simple as that. So now let's say I want to cut this. There are a lot of tools to do all this stuff. This is loop cut. Okay, shortcut is Control R. When I say Control R, it cuts in either of you can go to each face and it will direct you where the cut has to happen. Okay, now let's say I cut it here. I have taken my cursor here and it clearly shows where the cut is going to happen. Now I press enter. Now it will allow me to slide. Okay, if I don't want to slide, I can do escape and it has committed. Now what happens? Like I've created a new loop here. These are selection modes. One is vertex, one is edges, one is faces. Once in faces, I can select this, select this. Once in edges, I will not be able to select the faces, only edges. Okay. Once in vertex mode, I can select any of these vertices separately, or by pressing shift, I can. It's like folder selection. You press shift, you select multiple items. It's the same with edges. You select multiple edges by holding shift. Same with faces. Okay, I hope I'm clear. Okay, now I've clicked on this and I'm moving this. Okay, now technically it's on the path to become a house. Okay, so let's imagine this is a house. Okay, now the next thing that you need would be to render it. Make it look, the roof to be brown, the wall to be white or whatever color you want. There has to be a floor. Okay, now let's create a floor. Add mesh plane. Okay, now it's under the no, it's technically inside the house. Now look at the plane. You can select it here. Okay, and scale it 5 times. Okay, like let's say this is the ground that the house is on, but what you see is the house is below the ground. That's because the center pivot of this object is in the middle of the house. So you can either change the pivot or just move this object. I'm just visually moving it, but the actual value is 1 unit. GZ1. Sorry, GZ1. Okay, now it's exactly on top of it, not below it. Like it's overlapping. That's the reason you see this artifacts, because it's exactly in the same space. They're sharing the same space. Let's say this is your house. Okay, now the camera, what has happened? It is cropping the subject. So what we do, select this camera. Okay, I can move it. The way I move it is G, Y, X, Y, and Z. Okay, I can move it upwards. Okay, move it downwards or whichever one. So I'll make it little upward so that it is framing properly. In case I want to rotate the camera, same shortcut again, R, X. Okay, Y, Z. So it's like very simple stuff. Once you learn one shortcut, it applies everywhere in Blender. So now we are not rotating the camera. We are just already framed it. I'll save the file. And the file naming, of course, is very, very important. No, we have a certain way of naming stuff, model, texturing, animating. So we have versions as well. We have our naming convention as well. So now let's say this is your house. Okay. Now this looks very boring because it's gray. Now I can start adding materials to it. When you say materials, it's like real world. You'll have to understand what a material is made up of and put those things. As for now, we'll just use colors. We'll understand and see colors, then probably reflection and materials and stuff like that little later. So let's say this is your house. Once you have selected it, there is a default material assigned to it. We don't want that. We'll delete it. Now I add a new material, say wall. Okay. And make this some off-white color, but you're not seeing anything there. Okay. Because you're not in rendering view. You're actually in solid view. Okay. This is viewport shading. So there are modes to it. Wireframe. You're just seeing the wires. This is solid. This is material view. Okay, you have started seeing the colors which you are assigning here. This is the final render view. Once I start rendering, the GPU, CPU, everything will kick in and it will be heavy on this machine, but I'm anyway going to do it. Okay, so there is what you have started seeing is, you're starting starting to see the shadow and the basic shading. In the material view, you were not seeing all those shadows and stuff like that. So that's the difference between light material view and rendering view. So, and there is another engine called Cycles. Okay, Cycles is a rendering engine of Blender. So when you say rendering engine, you would have heard about V-Ray or Arnold or lot other Redshift and stuff like that. So Blender Cycles and Blender EV are the two rendering engines which exist inside Blender. So Cycles is this thing. Now we are still under material view. Once I start clicking on the rendering view, you start seeing lot more detail to it, like than before. EV did it very quickly. Okay, this is like super quick, but you still see artifacts in the shadows and stuff like that. When you click on Cycles, you don't see all those things. It's like super smooth, like, but it takes time. Okay, so I'm rendering on a CPU. As soon as switch to GPU, okay, give me a moment. GPU, the GPU is not enabled, I guess. So yeah. So these are preferences. So look at the difference of GPU rendering and CPU rendering. Okay, this is CPU. So you can see like it's updating very slowly. As soon as I switch to GPU, it's very quick. Okay, so GPU rendering inside Blender is very, very efficient. So we use GPU rendering most of the time. When you have a 4-core processor and render it, like there's a certain amount of time that it takes. The GPUs usually have hundreds of cores or thousands of cores. So all those cores can be put to use for rendering. So I would recommend learning a renderer which has GPU rendering enabled. Okay, Arnold has GPU rendering. V-Ray has started doing GPU rendering, but Octane is fully GPU render. It doesn't have CPU rendering at all. So you can choose certain renderers which are GPU centric. So you get faster feedback and faster renders. So now that you have seen how it would look with proper lighting and all, this light, okay, I've selected this light. Now it's visible outside this frame. This lighting settings is here. Either you can click on the green icon here, it will take you to this panel, or you can directly, if you're somewhere here, you can click on it, you'll get it. So this is a point light. Okay, right now I can make it into a sun. Okay, it has become super bright. Now I'll make it into 2 or something like that. Okay, so now what happens, it is behaving like a sun, exactly like a sun, with the proper 5 to 6 is the angle. So the sun angle, sun angle means, like, if you draw a line to one edge of the sun and draw another line to the opposite edge, the angle it forms is 0.526. Okay, that is the angle it forms in real world. Okay, so if you make it accurate, like, it will be physically accurate. The shadows, is like little softer. If I make it 0, it will be super sharp. Okay, this is never the case in any of the lights in real world. Even the filament has a width. Okay, so but these are faster renders. You can do it. If I increase it more, this is also not the case in real world, but most it could be like skimmer light, very diffuse light will throw shadows like this. So looking at it, you would have understood. You started seeing the camera, you started seeing the lights, you started seeing surface. This is how a movie is shot. Even in real world, like you have objects, you have lights, you have camera. So if you understand these three things, you'll start creating pixels. Do cinematography basically. So I'll just add few more colors to it. Probably I'll not go in detail explaining each part of it, but I'm repeating that what I did for walls. New roof. Okay. Now it's not assigned because it doesn't know where to assign. I go into edit mode. The shortcut is tab. Tab. Now I go to faces. I select this and say select this material and say assign. Now it's white in color. I would make that into, let's say, kind of brown. Okay. Now this side is not brown. What do I do? Can somebody help me on that? How do I assign the material right now? Now I am in object mode. Anybody?
Select, assign, and color. Like,
Yeah. Go to edit mode. Go to edit mode.
edit,
Select face. Then
assign.
select this material and assign. Okay. Simple as that. This is how much you'll need to know material assignment here, like forever. Okay. There's no other way to assign materials. Only like edit mode. Select roof, assign. That's it. Okay. Now you don't want roof, you go to wall, assign. This is how much you'll need to know. Okay. Now that you have this materials in place, so let's say this plane needs a material. I click on new. Okay. This is a new material. Let's say I need water. Okay. This guy is on water. Okay. Water is actually metallic shader with transparency. That's how it's constructed basically. Okay. Physically. So now let's say I've got a reflection, but this doesn't look like water. Why? Because there is no disturbances to it. See what I'm doing? I'm just splitting the screen. Okay. I'll do it once again. If you go to this corner, you will get a plus sign. Once you click and drag this way, you will get another window. Okay. Now this window is again 3D view. I can make this into any window that you see. This is a 3D view right now. You want an outliner, you click here, outliner. Okay. You click here, properties, which is this panel. Okay. You click here, timeline, which is this panel. You click here, 3D viewport, again 3D view. Now I am adding a new viewport, which is shader editor. Okay. This is the shader that has been assigned. You are seeing all these parameters here. It's the same here. Okay. Now this is an extra properties panel. I've closed it. So it's fairly easy. Okay. You either press N or click on this. Close this, click on this. Okay. You might not need it right now. So I'm just closing it. Now what you're seeing is, a lot of inputs which can be applied to all these slots. Now I am going to apply something so that it looks reflected. Okay. I mean, disturbed. Add texture, noise. Okay. Now I'm adding this factor to displacement. Okay. Now you can see that this guy, the water plane has started reflecting, uh, having disturbance on the reflection. So I can increase the size. Okay, I hope you understand. Okay. Now it's still boring because the environment is kind of gray. So let's add a new environment. Okay. Where do we do that? This is the world panel. Okay. It says background, the surface is background, the color is gray. Now I click on this yellow dot and say environment. Okay. Sorry, I'll do a sky instead. It says sky texture. Now see, it has created a sky, a default sky with horizon and all that. What does the sky do? I can It's kind of a sunrise that's happening if you notice. Okay, so it's like physically accurate sky. So it's like noon right now. Okay, and now it's at its peak basically. Okay, now if we want to go down, it's night right now. Okay, so it's like 90 degrees is what it allows maximum. Let's say I need somewhere here, but I need the direction to be changed. I just change the rotation, so it will rotate in the horizon. Okay, so it's like getting the environment for free basically. So it's like one single click and you start getting all these you know really accurate lighting. So now what we have done is made this into a water kind of thing, but it's still not very accurate. Just to give you an idea, I'm just doing all these things. Like I can make these materials very uh, physically accurate and all that. Now we can see, right? Like these reflections are in place. So this is a renderer. What it does is, there are three things to it: the surface, the light, the camera. Okay, the camera, we are not seeing through camera right now. It's a perspective. As soon as I go into the camera, I see what is being framed. This is the light. Okay, now the environment is giving you light, and this particular light, which is converted into sun, is also giving you light. Okay, I'll delete that. You'll still get the light because the world has some light. So I'll that the intensity is 0, you don't see any light from it. So technically there is light, camera, and the surface. Okay, there are ways to manipulate all these three things. That is how you create a pixel. So once you see everything here, and if you're happy with it, you click on render image. So this is how the image is getting rendered. Now we can see, it's taking a bit of time. It's 27 samples out of 4096. But you don't need that many samples. Like it's iterations. Imagine for 4096 as iterations. You need only as much iterations to reduce noise. So now the noise is kind of reduced. You're not going to see that much noise. So you will know it's only 300 samples you need. Okay. Now what I do, go to render samples is 4096. I'd say I don't need 4096. I'd say I'd have 150 and do a render. Okay, so once it's what 150 is complete, it'll stop. That's how it works. No, so it's like 144, and now it's denoising, and you'll not see much of noise right after the render. Okay, all the noise is cleared. So this is the render that we have created as of now. As in, you have created an object, edited it, assigned different materials to it. One is with lot of reflection, the other one is not as much. Okay, now we have rendered it. Now we'll need to save it. Okay, image, save as. Now it asks for formats. Okay, PNG, Cineon, DPX, OpenX, TIFF, and lot of stuff. Whichever you plan to use. In case you want to send it on a WhatsApp group, like nobody is going to color correct it, do a JPEG. Okay,
Sir,
probably you can. Sorry,
sir, the render view is not visible, sir.
sorry, rendering view was not visible. Is it? Just give me a second. Yeah, I'll no edit preference interface. Now, how about now?
Yes.
Yes. Okay. So now what is happening is, these 150 samples is getting rendered. Once this rendering completes, this will get denoised, and this noise will vanish basically. So let's just wait. So now the rendering is complete. The noise is clear. Now we have created all these pixels. You need to save it. Image save as. Yeah, you got your formats in place. No PNG, JPEG, Targara, whatever. Now let's say you want to send it to your friend on WhatsApp. Like you just do JPEG 100%, and you have a. No, I'm just saving it on a desktop. Like shade test pro one. Okay, then I save. Now what you got is an image. Okay, you have created this image basically. So this is the render that you have created, generated on your own. Okay, now the file format differences, like you'll need to spend a lot more. I mean, I think you were not able to see the image basically. Uh, is there a way I can share the entire window? I'm not able to do that. Let me try doing it. Okay, give me a moment.
So you can share your desktop actually.
Desktop, is it? Okay, I was doing the window thing. Okay. Okay, now I think, now are you able to see my desktop?
Yes.
Okay, yeah, so this is the image that we have created, from the 3D scene. Now what happens is, this JPEG can be sent for viewing purposes, but in case you want to color correct it, this is not enough. So you need to render it in a different color space, different bit depth to do that. I mean, you can spend time on it once you get there. In case you have some doubts when you're working on it, you are free to send me a message and I can clarify things. So no issues there. Now as of now, what you understood is, we have modeled it. This edit thing can be very complex, like, you can do whatever stuff you want to do. You can do hundreds of loop cuts and do all these things. And this is like, imagine this is modeling. Okay, you push and pull vertices to create something that you want. Okay, this is basically modeling. How structure it is, and how good looking it is what matters. Now I've just done random stuff. It will still render. I can just render it, and you still see a lot of stuff. Okay, so where you push your vertices is modeling. That of course is practice, observation and practice. So I'm not going to get into that now. We'll stick with our house. Okay, we'll save the file. Now what has happened is, like, modeling is done. Now the basic lighting is also done. Okay, you need like uh, some physics to happen, some basic animations to happen. So I'll go about doing it. Okay, so these are the elements that you need to create in a pipeline. Like, you develop the asset, shade it. I have not applied any texture to it, which is like, from external textures. I'll do a cloth simulation, probably do a flag simulation, and do a flag texture then. So that way you'll know how textures are applied and all that. So okay, I'm just saving. I've just downloaded a texture from the internet. Okay, now I'll go do a new file, delete this cube, file, import images as planes. Okay, in case you don't see this menu, it's because the plugin is not enabled. How do you do it? Edit, preference, add-ons, search for images, import image. It will be disabled. You just have to enable it, and you might have to save preferences and close it. You're able to see the settings, right? Yeah.
Yes, sir.
Okay, now I go here, import images planes, go to desktop, get this flag. Okay, now what has happened? You're seeing a plane here. Okay, you're not seeing the material as of now. Now let's go to material view. You started seeing the material. Okay, now I can do a simulation of this, like, cloth simulation of it. It's fairly very simple. Okay, did I just close the window? I think I did. Okay, are you able to see my screen?
Yes.
Okay, now what I do is I go to, this is the physics tab. Okay, click on cloth. Okay, I just clicked on cloth. We expect this to be a cloth right now, so I just play. What is happening is, it is falling, but it doesn't feel like cloth as of now. Okay, Why is it falling? Because it the gravity acts on the cloth and it's falling. But we need these 2 points to be fixed. So what I'll do, this is the data panel. Okay, data panel as in you can add vertices to a certain group and make them fixed in a cloth simulation. Okay, now I go to edit mode. I select this vertex, click on plus. Okay, it's like material. Just add one material kind of thing. It's a your only difference is you are adding a vertex group. And now say assign. What is what has happened now is this vertices are assigned to this vertex group called group. Now I'll name it pinning group. Okay, I'm just going to pin it. Where do I pin it? I go to physics tab. I'm going to a panel wherein it says, just give me a second. So under shape, you got a selection box called pin group. I go there, you'll see whatever you have created for this particular group. Okay, now it's pinning group. Now I play. Yeah. So now you see the simulation is not actually happening, but you would have seen a small movement here. It's a small movement which is happening. The reason is you don't have enough vertices to do the simulation, enough divisions. So what I'll do, I'm going into edit mode and right click subdivide. Okay, so I'll have to select the entire face, right click subdivide. We'll go to wireframe. I'll get rid of this cloth and come back here. Just give me a moment. I'm going to redo this again. There seems to be some issue in the imported plane. I'm just going to redo it again from the scratch. File, import, image as planes, desktop, the flag. Then I go into this. Okay, I was not able to subdivide it earlier, so I'm just going to do the subdivision right now. So I've added a lot more vertices and faces to it. Okay, everything applies. Now I go into edit mode and select only this vertices. Okay, I did that by clicking alt. Okay, alt clicking would select the entire line. Now I get into here, add vertex group, assign. I name it pinning group. I go to physics, add cloth, go to shape, do pinning group. Now if I simulate, you'll be able to see that this guy is behaving more like a cloth, but it's penetrating itself. Okay, now I can avoid that by doing collision and self collision. Just give me a second. Go to collisions and click on self collisions. Now if I play, it will be little slower, but it will collide to itself. Okay, so the smoothness of the cloth depends on how many subdivisions you have done. Okay, I've just subdivided like few times. You might need to do it little more times. Okay, so now what has happened, you got a Indian flag, which is doing its thing. Okay. Now these things, these overlaps are because there isn't enough subdivisions. I'll try to make it little smoother. This is the modifier tab. You can add subdivisions to it. Just give me a moment. So as you increase the subdivisions, what happens is, the calculation is getting very slow. That is because, it needs to calculate all these vertices, all these collisions and all that. And you're bound to get into more issues as you get, like, unwanted number of vertices. It's like, number of unwanted pixels. It has to process all these things. So I'll stick to the earlier version just to give you a fair idea. I think that's quite enough. So I'll just stick to that. No, this is it. Like, okay, now let's say you want to do a wind. Okay, wind to it. I'm just adding a wind to it, and I'm just rotating it other way around. And now if I play it, I might need to increase the wind speed. Okay, wind strength. Okay, so what it is technically doing is actually simulating the cloth, basically using the wind that we have applied. So this is fairly easy. Like, you can create, this is like 2 minutes job if you look at it. So this is one simulation. There is like, I'll quit this and no, start showing you a few more simulations that we'll be able to do. Okay. Let's say this is the domain mesh cube. Okay, I've created 2 cubes. Go to physics. I'm creating a fluid. Okay, this is the domain. I create another fluid. This is the flow. Okay, now if I play, just do this. I'm having a certain issue with simulation in this machine. I don't seem to get the regular this thing, but I'll show what is possible, whatever is available and all that. So there are lot of ways to simulate fluid and stuff like that. Let me give you an example. So what if you look at it, like, it's displacing all these objects depending on what's touching it. Okay, so it's like you can add snow kind of thing. You can add footsteps where grass is growing, or grass is going down kind of thing, and you can as well animate it. Like, okay, this is one way of doing it. This is displacement. Now I'll just show you waves. Okay, what happens once you play it? It will start creating waves. So these are like ways you can create certain effects. It's like simulating fluid. It's not actually physics based simulation, but you're just creating waves. So it's like you if you make something fall inside the water, you'll get all these effects, and you can make a boat go and it will create its wake probably. So these are like simple ways you can do simulations inside Blender, and I'll show you rigid bodies and stuff like that. This is again, go to physics, do rigid body again. So now what happens? This would fall and no do its thing. Just give me a moment. So, no, it will do its physics thing. Okay, I can add a mesh. Susan, this is called Suzanne. In there's a monkey, but it's called Suzanne in Blender. Okay, now I do a rigid body. It'll do all the physics, which is no. So it's fairly easy to animate real world stuff in Blender. So in case you want to do something character based and stuff like that, it's not that easy, that straightforward. It'll of course take time. But what I'm trying to showcase here is, there are things that we might need. For example, shading, lighting, simulation. Uh, you could simulate fire, you could simulate cloth, you could simulate hair. There is like a lot of ways you can generate hair here. You can create fire and smoke here. So, and it would all interact with each other. Like, one object can make the other one burn, and it's like, like in real world. So those things are fairly easy. Like any tool would have all these things. Now let me stop the screen share for the moment. So it's like, you'll be able to simulate all these things fairly easily in Blender, and render all those things as images, and give it into a composting tool. The composting tool is basically layering tool like Photoshop, but with image sequences. Now Blender has a compositor too. You can add live action video, add rendered images to it, and deliver a final output right away from inside Blender. So when you talk about pipeline, what happens is you create an asset, you do the texturing, shading, you animate it. Now I haven't shown you animation. Probably you guys would have already seen animation. It's like adding keys. Like, give me a moment. I'll just add few keys and show this is what animation is. And then probably. Okay, so this is the timeline. Okay, you go to the first frame, you press I. Okay, you get the frame, insert, the menu which is called insert keyframe. I say location and rotation, okay, of this object, and I go to frame 100. Okay, move it, rotate it, then press I, again location and rotation. Okay, so this is pretty straightforward animation which you have already seen in many of the other tools as well. Now any of these objects parameters, most of these parameters are animatable. Scale and materials and stuff like that. If you look at it, like, you can add a material color to it, and let's say I want this color to become. I just go over this and press I. It will automatically create a keyframe. Now I go to this frame. Like, I'll make it green and press I again. Okay. Now when you look at the render view, it's orange, then gradually. So you'll be able to animate all of these parameters, almost all of these parameters, to achieve various effects. Even the water that we created, we can make it move. Okay, we can animate the coordinates, UV coordinates of it, and it will look as though the water is moving. Probably I can show you that quickly. Give it a second, it is compiling the shaders. Okay, now I'll go to cycles. So now it's reflecting. Okay, now I'm just increasing the scale. Okay, now in case you want to animate the movement, you can do it. This is 0 meters as of now. I just add a key in the first frame. Go to 100, like add another key here, press I again. Now what happens, like this guy is moving. It's like very quick, but probably I'll do a slower one. All these ripples and stuff like that this can be rotated, or any of these parameters can be animated. So animation, of course, is like just depends on the tool and the observation of the user, basically. So once you animate it, once you render it, like it's pretty straightforward stuff. You get into the composter and layer everything, kind of thing. And you might be using different tools most of the time. Not, I mean, also, most of the studios don't use one single tool to do all this thing. We use Blender to do right from start to finish. But it might not be the case with most of these other studios. It will be like Maya for the rendering, animation and rendering, and Nuke or Fusion for composting and stuff like that. That asset creation part, like I just touched upon it. I know that, like it's nothing to fancy about, but what you should understand is, pixel pushing and pulling, vertex pushing and pulling is what modeling is. Okay, I can share one more thing, like probably it's a easier way of modeling as well. Give me 1 minute. You're able to see my screen, right?
Yes.
So this is the cube, like I go add a multi-resolution modifier. Okay, subdivide it. I can go to sculpt mode. Okay, sculpt is like the typical stuff, like ZBrush and all that. Okay, you can probably so in case you want to create a face, or whatever you feel like it, you I'm just smoothing it out. So it's like you get the idea, right? Like sculpting is one way of doing it, but like only thing is, it's super heavy on the mesh and all that. it's fun to do in Blender, you get a very quick stuff fairly very easily. So you can get to sculpt. You guys are more creative than probably I am. So just get to use the tools like to get the sculpting, and you can assign a lot of various. I mean, lot of materials. Probably it could be metal or mud or stuff like that. And sculpting is a very no, it's like regular painting. So you can spend a lot more time adding detail. It's kind of you can get into a trance while doing sculpting, not the other way. No, everything else is more technical. This is kind of art, so you can continue doing it. So these are the tools that probably you can use to get your assets in place. Probably do an image render for your project or stuff like that. But the idea is to create an asset, probably using sculpting or scanning, 3D scanning from the real world and creating it and shading it, putting it into an environment, lighting it, um, rendering it, making it into a end frame, like adding comp and effects to it and delivering it to the client. That's basically the pipeline that most of the studios use. Even in videos that you've seen, there is this motion capture thing, where you wear suits and move and record all these movements. It's like recording the mouse movement. It's like XY movement. Now the only difference is it's no XYZ movement. There's also the 3D axis which is being recorded, and you apply it to the skeleton of the characters. So that's how it is. So probably I think I should close. Basically, you can ask few questions. I've just broadly touched few things. I understand this might not be enough detail for you to grasp a lot of stuff, but in case there is more sessions or probably visits where I can spend a lot more time in interacting with you guys, with more, if you have more questions, I think it will be fairly easy. Yeah. Any questions that you have, I'm no willing to answer. Any even related to Blender or some other things, production or any other work related questions, I'm free. I'm willing to answer.
So can you share any work that you got?
Sorry.
Can you show us some examples that you
The
might
works
find?
that you have done, is it okay? So what did you see earlier, like just before the session, which may know, like the Talapakati ad is what you might have seen, right?
Yeah.
Okay, so I'll just
We saw this.
just
We saw this too.
okay, cool. Ranadhiran, did you see Ranadhiran? No,
Yes.
Ranadhiran as well. So I'm not sure what else to say. Probably I'll show you Kuti story then. Kuti story you might already have seen on your this thing, but you're able to see, right?
Yeah. So we can't hear. We don't have the sound.
Sorry, you're not able to hear, is it?
Yeah.
Sir, we can see the visuals but not the sound.
I'm not sure how to share the sound. Is there a way
Type
to
of
do it?
sharing your desktop, you should enable share PC audio also.
Okay, include system audio. Thank you. Yeah.
No, English.
You able to hear now? Hello? Are you able to hear now?
Yes, sir.
Okay.
Listen, bro.
So that's one of our work. I mean, what's special about it is, just give me a second. it was all done in 10 days time basically. So we were able to do that because we used 3D but made it look like 2D. No, it was not done hand animated. So all the chalk piece and ballpoint and everything we stylized all 3D to make it like 2D. And, uh, so the idea was to uh, use elements which usually we find in colleges, Xerox machines and boards, and people scribble on notebooks, and there would be flip books and sketch drawings and stuff like that. We tried most of these styles to match that kind of, and the environment, the notice board and stuff like that. We try to. It was a college based stuff, so we tried to do that, but we were able to achieve that just because we use 3D. Otherwise, like hand animated or very similar stuff with corrections, it would have been very difficult. We wouldn't be able to create a lot of camera moves and stuff like that. We were able to do that because of 3D and Blender. Yeah.
Sir,
Okay.
I have some query about the movies. Like in animation movies, that characters are designed in Maya or Mac, and they are assembled with Blender software like that.
Not actually, like most of the time very high end movies are done in one package. Animation and rendering happens in one package. The visual effects stuff, like uh, creatures and stuff like that, they animate in Maya, they bring it into live action. That is when like few other tools get combined. So but 3D animated movies mostly happens inside Maya or 3ds Max or Houdini or Blender. uh, it's mostly one package, because once you animate it, all the rigs and controls, transferring it to another package is quite difficult.
Yeah, sir.
Not fair.
So you told like that we need the character design for character design. You need Mac Maya like that. Na, sir, you told.
Yes, I told. The thing is, a studio basically usually doesn't deviate from that. Okay. In case you want look development to happen in a certain renderer, they usually take stuff outside of it. For example, Octane is a standalone renderer. Okay. So you usually don't get Octane embedded in most of the software. What happens is they export formats like Alembic or USD. Okay. It comes with all the particles and materials. Everything is exported as a single common standard format. Then that format is read by renderers. Even like there are tools by Nvidia coming up lately called Omniverse. You can work from Blender. One guy will be working on a character in Blender and it will be exported as USD. One guy would be doing the environment and rest of the characters. Okay, those things will assemble in USD format, and Omniverse is the tool which will assemble all these things. Once I can update in real time, and everybody can see the updation in real time as well. So there are tools which are being built to combine all these things, but initially and even today, not many studios combine different software for different phases of it. Maya based studios do Maya stuff, but we combine, like I get, like, we worked on the KGF 2 trailer recently, so they animated in Maya and we did the look development and effects and all that. So the car chase sequence and destruction sequence we did. So there is handshake between two tools, but it's not very common. Okay, it is possible. We do it because we do it in Blender. They don't have any. We do very good stuff in Blender. They want the work quality, but they're not able to make us use Maya. So they are okay with using Blender. We using Blender. So that's the reason we handshake that way. Otherwise, most of the studios stick to one tool or one similar pipeline.
Yes, sir.
It's doable. In case you want to do character animation in Maya, you can do it. Export it as Alembic or USD. It will work perfectly fine.
Okay, sir. Sir, I have lot of questions, sir, but this time not coming in my brain. Sir, can you
That's
please
okay. You
today?
can write it down. Probably send an email. No, you can send to Dinesh sir and Hari sir, and they'll reach it to me. Or you can get my email ID from them also. You are free to email.
Okay, thank you.
So, but I've been telling, questions are important, but I don't get I don't get to see many questions from your end. Okay, so probably you can add that one more thing. No, ask more questions as one of the messages from this session. Anybody? Nobody?
So may I ask some feedback from the students?
Yes, please.
So it was really a very interesting session.
Thank
Actually,
you. I'm not able to see the speaker as of now because, the camera isn't tilted to the right. Basically, I can see only, 3/4 of it. Yes. Yeah. No, I think I can. Yeah.
I could really learn many things about Blender. I have never used it, but yeah, I guess I can now. Thank you so
Right.
much, sir.
Thank you. Thank you so much.
Thank you, sir. Thank you, Arju. And I request Vrinda to do the vote of thanks.
Om Amriteshwari Namaha. We are absolutely grateful and obliged to have a session with Sivaprasad sir. It was very informative and interesting. Thank you for your time, sir. Looking forward for more sessions with you. I thank our Director and Dean Krishna Kumar sir for providing this opportunity to conduct this event. I also thank the strong pillars of our department, our HOD Dinesh Babu sir, class coordinator Hari Krishnan sir, and all the other faculties for organizing this valuable event. I also thank each and every one of you for your participation. Thank you.
Thank you so much. Yeah. Okay, sir. So I'll take leave then. I'll get in touch.
Thank you, sir.
Thank
For
you.
joining us, and we hope we will be meeting you again in campus.
Right. Sure. Definitely, sir. Thanks for the opportunity and thanks everybody. Yeah, for joining in. See you then. Bye.
Thank you.